Hey, what's going on, everybody? We'll wait for some more people to get. Uh, wait for some more people to join before I. I should probably post this. So let's start off by, this is the program I've written here. We'll start off by showing you what it does. Run the program. Alright, so we enter our principal amount. Our interest rate, we'll say 5%. Number of years, we'll say 5 years. And number of times compounded annually, we'll say 12. Then it outputs how much money you're going to wind up paying, per year. So basically what the formula what this does is, here I'll pull up the formula I used. Let's go to the website. There we go. How are my levels? My levels are pretty good. That's what's up. Alright. We'll go to do this. This is the formula I used. So, yeah, let's go ahead. We'll even use this example. We'll run the program using the example provided on this website, just so I can show you that the math is correct and that I'm not, I'm not crazy and that I know what I'm talking about. Close one of them. I didn't have to have both of them open. I don't know why it was two, but okay. So we'll go ahead and run the program again using the information from the formula website. So their principal investment is $5,000. Enter. And this is in a savings account, so their interest rate is 5%. So we'll do that. Number of years, 10 years. And the interest rate is compounded monthly, so there's 12 months in a year. So we do 12. And then, after 10 years, your loan or your interest will have accumulated to $235.05, just like it says down here. And they simply, this is the formula they used. This is all the data that they kind of crunched before plugging everything into the formula. So how did I go from this formula? So how did I go from this to the program that I just made? Easy, I'll show you. First, we'll start off by File, New, Project. You do C# application. We'll go ahead and name it. Let's name it Compound Interest Demo Live Stream. Actually, let's just call it Live Stream. And we'll hit enter. That'll bring this up. Alright, first thing I want to do, since we're using the console, we want to do using static system dot console. Perfect. And what this does is, so that way I don't have to keep writing console.writeLine or console.readLine. I can just simply call the method writeLine and readLine without having to add that extra text. It's fairly simple. So first thing we'll do is we'll start the program with a simple writeLine method. And we will ask for the principal value. or the amount you're investing or you're going to be borrowing or getting a loan for. So enter principal amount. And you always want to end your line, every bit of line, with a semicolon. So then we'll go ahead and we'll create a variable. Oh, I'm sorry. First thing we really want to do is we got to go ahead and let's create our variables first. Double. They're going to be doubles. A double, for those of you who don't know, is a type of variable. It is a decimal variable, but it only goes to the hundredth place. Since we're using finances, obviously we only want to go to the hundredth place. So we'll go ahead and we'll create one called principal amount, comma, and now we're going to be defining a whole bunch of double variables, so there's no point in creating individual double variables by typing double name, double name, double name. We might as well just go ahead and get them all done right then and there. So we're going to need the principal amount. We're going to need interest rate, and then we're going to need annual compound, how many times the interest is going to be compounded annually. And then the last one is, let's see, oh yeah, for how many years. So we'll do principal time. There. Now, for those of you who are freaking out, like, why is my compiler telling me that these are wrong? What are these, green marquees underneath the text? All Visual Basic is telling you is that all Visual Basic is telling you is that I haven't used these variables yet. I've just defined them, and that's it. I don't know, what else there is to do about it. I don't know. It'll go away once I've defined the variables, which we're going to do subsequently as we keep writing the code, because this is dependent on user input. So obviously we we'll have to adapt. What God's name is going on? Am I still even on the... Okay. Cool. So the next thing we'll do is, now that we've asked the user for the principal amount, we'll go ahead and we'll do a read line. Better yet, let's do this. We'll go ahead and define what our principal amount variable is going to be. And because the input is going to be a string, we're going to we have to convert it. So voila. And what this line of code that I just wrote is, it takes the principal amount variable. You see how it's no longer got that green marquee underneath it. And it says, okay, read whatever the user just inputted after this, and go ahead and store it. First, convert it to a double, because that's what this variable is a double. And then go ahead and store it as the principal amount variable. Awesome, cool. Next thing we need to do is, again, another write line. And this time we're going to ask for the interest rate. So I'm simply asking the user enter interest rate without the percent symbol, and we could probably do a better job spelling percent. Good thing this is a programming class, not an English class. If it was English, it'd be pretty bad. Alright, now the next thing we'll do is we got to go ahead and convert this interest rate that the user just entered into a double variable, which we've already defined. So we'll go ahead and do the same thing we did with principal amount, except this time we'll do it with interest rate. So we'll type interest, yep, right there, and assign it to a convert method dot to double, perfect, read line, and then finish the method off in semicolon. What I really love about Visual Basic is, or not Visual Basic, Visual Studio, any version. I have 2015 because I'm cheap, but what I love about Visual Studio is it goes ahead and it has an intelligent IntelliKey or whatever it's called, where it kind of predicts what you want to write, and it comes up with the right thing you want 90% of the time. Or it gives you options, and that's also another way to help you with debugging, because it'll show you whether you're on the right track or not for typing in a command. Like, there's been plenty of times where I'm like, how come I can't write something, wait, it's not popping up, okay, I'm not writing it right, let's go ahead and take a look and see what I'm doing wrong on the internet and see what I can do to fix it. So the next thing we'll do is we'll go ahead and we need to ask the user for how long their loan or investment is for. So we'll do another write line. See, here I'll show you what I was talking about. I started typing the W, and it already pops up with what exactly what I want right here. So you can do write line or write, or you can do these other systems right here, but I'm going for a method. So we'll go ahead and you want to hit tab when you find the right one. You can also use the arrow keys to move up and down that list. Here, I'll show you. So you find what you want, you use the arrow keys on your keyboard, up, down. Instead of hitting enter, you want to hit the tab button. So if you hit enter, it may also accidentally do a return, which you don't want when you're writing code. So write line, enter length of loan, enter years of loan or investment. And end it with a semicolon, as usual. So then we'll go ahead and we will define our principal time variable. Except it's not a method, so we don't need to do parentheses, equals. And yet again, convert that to double read line, parentheses, colon, semicolon. Now, last thing we need to do is we need to ask the user again for one last thing. How many times is the interest going to be compounded per year? Usually for interest, it's compounded annually. Maybe sometimes it's compounded 6 months or once a year. Who knows? It depends. It all depends on your loan. But for the most part, you're going to be compounding once a month. So let's go ahead and do one more right line. We'll do enter how many times interest is compounded annually. You know what, let's go ahead and clean up the formatting a little bit. So I forgot to do this for the others, but I did it with the first one. It's not necessary. I just like to have it formatted this way because it looks more professional and it's easier for the user to understand. So, and then we'll go ahead and we'll define what the variable is going to equal, annual compound. And now, as you see right here, all these variables no longer have those green squiggles at the bottom because we've defined them, or we're using them at least. We'll do one last convert dot to double read line semicolon. So great, awesome. Now we have all our variables set up. Now all we got to do is calculate. So the way we're going to do this is we're going to use a loop, and it's going to be the for loop. And the reason for the for loop is you want to use for when something is true and not true. So basically, what this program will do is it'll show up on the screen how much interest and how much total money you're going to either be paying or gaining per year, and it'll show you how much money you're making or losing if it's a loan per year, all the way up until your final year, so long as nothing changes. So we'll go ahead and start writing. We got the for loop written, and we'll do parentheses, and we'll define an integer. Call it t for time equals 1, semicolon. And then if t is less than years plus 1, then add 1 to t. So that's basically what it says. We defined an integer t, which is going to equal 1, and if years is greater than t, it's going to keep exporting all that. Oh, sorry. We want to use principal time. I was thinking of a different formula that I had written, but So basically, if t is greater than principal time, then the variable, the amount of years that you have the loan, it's going to keep adding 1, and it's going to keep running the formula we're about to type out over and over again until it's done and proper. So our next step is to do a curly bracket. And here we're going to define a variable. It's going to be called total. And the reason for what I just did here is we want to keep total at 0. 0 will always be total no matter what until we run this loop. So this is where we're going to go ahead and we're going to take the principal amount, just like the formula we have here. We're going to do principal amount and then we're going to do multiplication. And now this is the important part. This is an important part. As you can see in this formula, let me pull it up. We have an exponent. Right here. It's really difficult to deal with exponents in programming. C# isn't really kind of meant for it. A lot of programming languages aren't really meant for it, but there's ways to work around it. One of which is the math.pow method, and this is how we'll set that up. So normally with math.pow you would do math.pow, okay, parentheses, and say you wanted to square, say you wanted to square something, like let's do 2 squared for example, 2, 2. That's what 2 squared would be using the power method. Obviously we want to end it with a semicolon, so that way it's correct. That's exactly what what squaring something would do. If you want to cube something, you just change that to a 3. So the first comma is always going to be the number you want to apply the exponent to. So for 2, then the 3 is the actual exponent. So we're saying 2 to the 3rd power, which would give you 2 times 2 times 2 is 3. 8. Ha! I knew that. 8. So for this, you could theoretically say, you could theoretically make all these parentheses right here, or even better yet, make this its own variable right here. You could do that, but it's not advised. Same thing with all this right here. It's kind of actually easier and more mathematically correct to set it up this way. Plus it saves memory because there's not as many variables being saved to memory by doing it the way I'm going to show you. Also, I totally forgot to explain this part. For the percentage, you want to add a division operator, and you want to divide it by 100 to convert it into a decimal. Otherwise, you'll get some pretty crazy numbers, and you'll think you'll owe more or make more money than you actually do. So now what we need to do is we'll go ahead and let's do this. We will do the first part of our formula right here. We'll do, yeah, basically the first comma is going to be all this stuff right here. So that's what we want the exponent to work with. So we'll do 1 plus your interest rate divide by your annual compound. Awesome. And one more thing, we want to do a parenthesis here and a parenthesis here. That's telling it to work with these two right here alone without doing anything else. And then, you know, to stay within, just like the regular order of operations, you know, the same applies. It's going to treat this statement right here separately from this next statement that I'm going to type, which is simply annual compound times t. And there, that's the simple formula. Right now, we've calculated all your compound interest to total, and now what we have to do is, and it'll calculate all this. It'll calculate your compound interest for all years, so long as t is still less than your principal time. It will keep calculating all that, but now we need to output that to the users so that way they know what's going on. So we'll go ahead and we'll do another right line statement. And we'll do your total for year, curly bracket 0, curly bracket, space, plus is 1 F0 dot slash n colon comma. Now we define the variables. Basically what I'm saying is, alright, this 0 is going to, you're kind of basically using an array to define your variables. It's just easier to format when you're programming as to typing t, comma, and then total. And now this is another thing, just because this is a double doesn't mean when we convert it back to a string for the output it's going to include the decimal point. It actually won't. It'll show all your numbers as a whole number, where we all know that there's going to be some decimals, some change involved. So we go ahead and do total dot to string and then capital C. And the reason for this capital C is that is the formatting for currency, because that's what we're using. We're using dollars. So we could even go ahead and do dollar sign right here to make it look even more pretty. So let's go ahead, run the program, see what we have. Oh, I forgot one more thing. We'll do a read line. What this does is, as opposed to the program just cutting off and turning off, at the end it'll still stay up until the user closes it. So that way they can, because the program will just close itself once the information is calculated. So let's go ahead and use the same example right here. Good job. There you go. And we'll use the same example just to make sure it's working right. Okay, so the principal amount is $5,000. 5, 1, 2, 3. Enter. Percent is 5%, and it's a 10-year investment. Okay, compounded once a month, so 12 times a year. Enter. And apparently we have an issue. What? Oh, I know what the issue is. We forgot a closing curly bracket. There we go. See, it ran. Oh, I don't even need to add I don't even really need to add this dollar sign because it'll always show it since it's got a currency. So let's try this again. So numbers looked a little off. So $5,000, enter. 5% interest rate, enter. 10-year loan, and compounded 12 times. That's not right. So it's important to know how to debug as well as anything else. Make sure I have the formula set up right. Oh, I know what I did wrong. Principal amount. There we go. Now it should work. I had the wrong variable. So okay, our principal amount again is $5,000 and 5% interest rate, and then 10-year loan compounded 12 times annually. And then that comes out to the same number we have right here, $8,235.05. Makes a huge difference when you're writing when you have the right variable. And this will work for anything else. So say you have a car loan that you need to pay off. Let's go ahead and let's use some real world examples. Let's look up some car loan interest rates. Ooh. Let's see what Bank of America. Oh. Oh, that's funny. All right, so we got these interest rates. These are APR, which is different. An annual percentage rate. Basically, they change. The interest rate can change throughout the year. So we'll just go ahead and we'll do 2.99% for some of these. So we'll say we want, you know, let's say a 40, you know, and how long are car loans for anyways? For 60 months. Okay. So 60 months doesn't really help. We'll divide that by 12 to see how many years. Which is 5 years. 5-year loan basically. Cool. All right. So let's say we get something nice. We get like a Mercedes Benz for like $80,000. Cool. And our interest rate is going to be 2.99. And then and it's going to be a 5-year loan, compounded 12 times a year. So you're going to wind up paying $92,883.01 for that Mercedes-Benz in 5 years. And that's also important to show you why it's important to keep your loan at a short time. Because we could, you know, say it was a 10-year loan. If it was a 10-year loan, we'll do $80,000. And we'll do the same percent interest. And we'll do 10 years this time. And it's still compounded annually. You wind up paying $107,840,000 in 10 years, as opposed to just paying the $92,000. You know, you wind up paying more. Now, this is also good to show you. Say you have a bank account, a savings account. And say you put $80,000 into that bank account, and they compound, and it's the same interest rate, and you leave it in there for the same amount of time, 10 years, and then it's still compounded monthly. So that means if you had that $80,000, even just for a 2.99% interest rate, if you left that in for a decade, and it was compounded, you know, annually 12 times, you would have this much money in your savings account. You know, as opposed to 5 years where it would just be $92,000. So it's also important that what I'm trying to tell you is you should save your money, especially if you have a savings account that offers you interest. Because the numbers don't lie. You'll have that much. You know, it depends on what your principal investment is. Let's say we got a tax refund of $1,000, and let's say we have a 5% interest rate, compounded 12 times annually, and we keep it in there for like 5 years. Let's say 5 years, and 12. So you'll wind up getting, you know, $1,000. You'll wind up getting $283.36 in profit from just keeping it in your bank account for that long a time. The banks are willing to give you that money. That's kind of how interest works. I highly recommend it. You know, it's a great idea. But yeah, you don't want, if you're going to go and get a loan for something, you do want to try and get it paid off quickly. Let's go ahead and let's do one more example of mortgage rates. Costco, that looks. Let's do. Let's make it a little more realistic. What about that? What about the average? And down payment, I'll go with that. You know, let's do a little. Well, nothing. Just show me. Okay, all right. So mortgage rates could be a little higher because you can do things like a 30-year fixed, or you can do APR, and your monthly payments are right there. So for a mortgage payment, we could actually just add, or we could just actually add your monthly payments for like credit cards and stuff like that, just dividing by 12, simply, the end numbers, because of showing you in what you're going to be paying at the end of each year. So if you split everything up by 12, because there's 12 months in a year, that's all we would have to do is divide by 12. In other words, this whole line we would just divide by 12 once it's calculated. Easy. But let's do an example for our mortgages. So let's say we have a $650,000 home because we're balling, and that's like medium price for my county. Enter. And we're gonna do a 4.25 interest rate, and that's a little steep, but whatever. And then how long do we usually? And I say it's steep for a mortgage rate because you typically you're going to be paying for a while, seeing as how the money is so big. So, and 30-year fix. We'll say 30 years. Jesus Christ. So we'll say 30 years. And it's compounded 12 months a year, or 12 times a year. And you're going to wind up paying just in interest alone, or not interest alone, you're going to be paying $2,320,922.16 compounded interest. Oh my God, that sucks. So let's do like I said. Let's go ahead and let's see how much the monthly payments, and see if it compares to these right here. Let's see how much your monthly payments are going to be. Divide by 12. Okay. And we'll go ahead and add per month so that way it makes sense. So go ahead and F5 it. Run the program. Let's minimize this because we want to compare it to this BS right here. But yeah, $1,600 a month is not that bad, I suppose, for a mortgage. But when you calculate and see how much interest you're going to pay, that makes me kind of squeamish. So let's go ahead and we'll do the same house price, $650,000. Enter. 4.25% interest. 30-year fixed. Compounded 12 times a year. Enter. And your first year you'll be paying a lot of money. This is awfully ridiculous. Like, I don't think I got my math right on this one. Let's see if we can look up a formula for monthly payments. Oh, okay. It's a completely different formula than compound interest. Because basically all I showed you was how much you're going to wind up paying in interest per year. You would use a completely different formula. This is the formula you would use to calculate what your monthly payments would be. So we would have to go and program this, which actually it does not look that difficult at all, honestly. So by number of periods. So number of periods would be like, how many times are you paying? I guess per year, which would be 12 times a month, because that's how they're calculated, obviously. But that should do it for now. That should be how to this is how to calculate compound interest. You could save it. Save it, and yeah. If you liked my video, please leave some comments, good or bad. I don't care. Nobody really seems to watch, so say something. Hopefully positive, but I really don't care. I'm gonna keep making these. Thank you for watching, and this is always fun to do. It's kind of trippy. And stay cool. Stay black. Peace.